Thank you so much for joining my session on high availability and disaster recovery. I'm Anil Kumar. I'm a product manager at Couchbase. I'm responsible for our flagship product, Couchbase Server. And also, I'm happy to mention that we successfully launched one of our monumental releases in the company's history, Couchbase Server 3.0. So if you guys have attended the keynote presentation yesterday, so Ravi mentioned that it's a big milestone for the company. The reason is we have made some substantial changes in 3.0. So some of the architecture changes we have made in 3.0. That further strengthens our core architecture. And in this presentation, I'm going to talk about what are those architecture changes and how they're going to amplify the high availability and disaster recovery features in Couchbase Server. You can stop me in between and ask questions. Because the session is like just 40 minutes, I'll be outside the room after the presentation. You can come and catch me later. So agenda for this presentation is quite simple. The part one, I will cover the technologies we have for high availability, which will make your job easier. Like you can relax. The second one is disaster recovery, which is how do we protect your data in case of catastrophic failures. And again, you can sleep well in the night. You don't have to be disturbed. Right? So, and we'll have a demo in the end, which will be the best part of the presentation. I will go through a live demo, and I'll show you the features we have in Couchbase Server for high availability and disaster recovery. So so the part one of the high availability. So before we get on to the discussion of what technologies we have for high availability, let's basically ask a question. Let's answer a question. So what does data unavailability means to your mission critical application? Let's assume that we have a e-commerce application, a online store, and it's a Black Friday sale, right? And now that most of the people have stopped going to the Best Buy or Target, standing in front of the line, they prefer sitting at the comfort of home and buying it online. So in this scenario, a few seconds or a few minutes of downtime means a huge business loss in the business value in millions of dollars, right? So there are key principles of high availability. So I will list down the key principles. The key principles are, first one, eliminate single point of failure, right? And how do we do that is by data redundancy. So you can create multiple copies of your data so that in case one single component or one single system server dies, your entire system is still up there and it can basically support your application. Right. So second one is detect the failure and recover from the failure, so that in case if there is a failure, you have the technology that it can basically auto fail or you have ability to fail over the server quickly, so that your application doesn't see the downtime. Right. And the third one is for the disaster recovery. Right. So if there is a catastrophic disaster like the data center going down or power outage, how do we handle it? Right. In this case, we need to have a geo redundancy. So you need to have the copies of your data, active data, in different data centers across the globe in different geolocation. So in case if your whole data center goes down, you have the availability of data in the different data centers. Right? So now let's look into the what technologies we have in Couchbase Server and how do we achieve the high availability in Couchbase Server. The single node architecture of Couchbase is the foundation for high availability and easy scalability. Right? So I'll emphasize once again, the single node architecture of Couchbase is the foundation for high availability and elasticity of adding more servers. Right? So easy scalability. So here is a single node of a Couchbase server. Every node of Couchbase server are identical. So if you have a 10 node cluster, all nodes in a cluster are all identical. So they will have the exact same instances running. So we don't have master slave or adapter or router and those kind of instances. We just have one instance, and you will have two processes running in the instance. I'll open the curtain. So you'll have a data manager and the cluster manager. Data manager is written in C and C++. If you're not familiar with Couchbase, so data manager is written in C and C++, which handles all the data level activities. Which includes in-memory database, your managed memcached layer, persisting to the disk, replicating to the replica servers. All is handled by for the data manager. The other side, which is cluster manager, is written in Erlang, and that handles all your cluster level activities, like adding more servers, removing servers, monitoring your Couchbase server, configuration management, security management. All of them is handled in the cluster manager. Okay, so again, the single node architecture gives us the ability to easily scale. Let's say you need more capacity. And going back to the example, again, if you have a Black Friday sale and you need more capacity because there are millions of users logging onto your site, then you need to add more servers quickly. So that the single node architecture gives you that flexibility. You can add more servers quickly, you can remove the servers without affecting your application. And also, a bunch of these things I'll cover in the demo. I will show you how easy it is to add servers or remove the servers. Okay. So I talked about the key principles and how do we eliminate a single point of failure. So the solution is the data redundancy. So in Couchbase Server, we have intra-cluster replication. So here's an example of a Couchbase cluster. You have a 3-node cluster, and you can see that we have active and replica partitions distributed across this cluster for the servers. So each server will have both the active and replica partitions. The replica partitions of the active nodes are in this another node, so that if the node goes down, we still have the availability, right? So in this case, the intra-cluster replication is the replication between the nodes within a cluster, and it is RAM to RAM, which is like from memcached to memcached. So it's very super fast. The goal of the intra-cluster application is to, as quickly as possible, send the data out of the server, so that in case of so that we have the durability. So in case if server goes down, we have the availability. And also we have, so you can create max of 3 copies of your data. So totally we'll have, including the active copy, we have 4 copies of your data in a cluster, right? And another thing we have done is a bandwidth optimization. So what this is like, if the same key get updated, like same key gets mutated in a fraction of a second, we don't send all the mutations to the replica servers. We send the latest copy. Even with that, our goal is to send the data out quickly out of the server. So most of you who has the Couchbase deployment would know that this is not common. This is common. Like what's new in 3.0 is I'm going to talk about that in a little bit. How it's going to change? What's the performance benefits we have seen with the 3.0 and everything. This is a common write operation. So you'll see that the document comes to initially to the memcached layer, asynchronously gets written to replication queue and the disk queue. The data it gets sent to both replication queue and disk queue at the same time. The reason is, not only we persist the data, we also want to send the data as quickly as possible out to the other server, right? So this is there even from the beginning of 2.0, so it hasn't changed. But what has changed is we have new protocol, and I was talking about some substantial architectural changes, right? So, and again, throughout this conference, you might have heard about this acronym DCP, and you might already know what DCP stands for. It is Database Change Protocol. Database Change Protocol is a new streaming protocol in Couchbase Server. It's basically like a hotline for the product, right? So every other component, like downstream components, you can see I have listed out a lot of components here. So we have incremental rebalance, cross data center replication, intra-cluster replication, incremental backup restore, all powered by DCP. So all of them are powered by DCP, right? So the reason DCP is much advanced and much robust is because it has a lot of new capabilities. And that's one of the reasons why we took a year and a half to build this product and ship it, right? So the DCP is a underlying, like there was a lot of analogy given in yesterday's keynote presentation about putting a new freeware structure itself in the city and all. That's exactly right, because this is going to change the whole system in terms of performance, the high availability, disaster recovery, and all the stuff, right? So what's new in DCP is it has ability to do ordering on a per vBucket basis. vBucket in Couchbase is a single data partition. So we create 1024 logical partitions. And so DCP has ordering capability on a per vBucket basis. So what this ordering gives is basically you know exactly where it left off. So if it's a rebalance, you can do incremental rebalance. If it's a backup, you can do incremental backup. So and there's a feature I'm going to talk about in the later part of the discussion about delta node recovery. What that means is if you add the server back, you know where it left off and how much you have to catch up, right? So all these abilities because of the ordering or the sequence numbering. Okay. It has a few other things. It has there are a lot of things actually. So it has the snapshot ability. So it can take the snapshot. It gives you a consistent view at that point in time. And also it is useful for batch processing. So basically, all the consumers of DCP, like for example, Vue is a consumer of DCP. When it makes a request, basically it takes a snapshot of what's in memory, and at that point in time, and does the update for the Vue, right? So it's consistent, and so exactly it knows what data was in the memory at that point, and also it does the batch processing along with that. Likewise, the rebalance operation. Rebalance is going to be powered by DCP. So it's now knows, this basically, we talked about push and pull model. Before it was more of like a push model. We kept pushing the data to the replica servers. Now we know exactly how much we have to send to the replica servers. So it basically does incremental rebalance. So it's much efficient. And one of the tests we have done, and when I talk about the write operation in the previous slide, most often the question comes to me is like, so if we have important data, how do we guarantee that data is persisted to the disk or gets replicated to the other servers before you send an acknowledgement back to the client? So we have two APIs in Couchbase, the persist2 and replicate2. What persist2 does is basically it guarantees you the data gets persisted to the disk, only then the acknowledgement is sent back to the client. Or if you use the replicate2, it will guarantee you that the data is persisted to the replica servers. If you have multiple copies, it waits for how many replicas you want to persist to, and then sends the acknowledgement back. So what we have done, there's one example of the testing we have done in 3.0, performance testing. And what we have seen is when we did the testing with the 2.5 and 3.0 comparison for the replicate2 latency, we've seen 150x latency improvement, performance improvement. So what that means in terms of high availability is you can replicate the data much faster to the other servers. Again, this improvements we have put number here is again in-house testing on the workload. You might see a different number, even you might see much better than what we have seen. So the goal here is like to understand in terms of high availability what this means. In terms of high availability, this means that you replicate the data very quickly to the other servers. In case if there's a system failure, you have the availability of the data. So that's what the DCP provides in terms of intra-cluster replication. Any questions? Okay, go ahead.
Is the replicate2 is configurable? Let's say I have 3 replicas, I just want to make sure replicate2 happens only at least at one, and then I want
Yes. That's a very good question. The question was, can we make sure that replicate2 can be configured on only one replica or 2 replicas? Yes, absolutely. So we can configure and say we want to replicate at least to 1 node or two replicas or 3 replicas. So you can create max of 3 replicas. And also these APIs are key by key basis. So you don't have to basically do this for all the keys. So if you have a certain amount of data which is very important and you want to guarantee the persistence, you can use this replicate2 APIs for that. It's a client API, exactly. So it's a client-side API. Okay. So next architecture change I'm going to talk about. Again, there are a lot of other architecture changes we have done, but I have picked the architecture changes which is useful for, which is more relevant for the high availability and disaster recovery. So there is another architecture change we have done is a auto-tuning shared thread pool. So back in 2.2, in Couchbase Server 2.2, it was released last year in September. We released a feature called multi-reader writer. What that feature provided is basically it gives you the ability to define number of reader and writer threads on a per bucket basis. You can say on this bucket I want to allocate 8 threads, and so we internally, depending on the workload, we can allocate 4 threads for reader, 4 threads for writers. But the limitation with that feature was like if you are deploying to a very beefier machine, like you have a 24-core machine, and just by allocating 8 threads, we are underutilizing the machine, right? And also another problem was if you have multiple buckets, if you define 8 threads on a bucket, it's not shared. So in case if the bucket is idle and the another bucket has a heavy workload, we are not really efficiently utilizing the resources. So what we have done with the auto-tuning shared thread pool is we have advanced this feature. We made it much more robust. How does it help is like basically at the startup time, when you create the first Couchbase Server instance and the first bucket, the engine looks at the system resources. It looks at what hardware, how many CPUs are installed, how many cores of CPUs you have. Depending on the number of CPUs, basically it allocates at runtime dynamically number of threads. Right? So if you have a 24-core machine, we allocate the default number of threads. And I can explain if you want to catch me later how we calculate that. Right? and it's again configurable. It can, if you choose to go with little higher number from what we have set the default, you have an option to change that default settings. So how this helps is basically in terms of durability, right? Because you have a pool of threads ready to take on any task which comes up, it's getting much better in terms of not only reader and writer, but also we have these threads are used for every other calls. We have a background fetch call for key lookup in case of a new feature we have released, tunable memory. So that's efficient. Warm-up operation, which is basically when you bring a node back, we do a warm-up operation. We load the active data set in memory. That usually takes a long time because we have to, before with the value eviction, we had to load the whole key and metadata in memory, right? So that warm-up operation used to take a lot of time. With the new, with this shared thread pool, now the warm-up operation has significantly improved. Which like the time duration it takes for warm-up operation is cut in half in 3.0 because of the shared thread pool. In terms of the testing we have done, so we have seen that with the shared thread pool, I talked about the persist2 API, which is basically persisting the data to the disk. We've seen up to 3x performance better in performance gain in 3.2 because we have a pool of threads ready to take on any task, right? So it's and on a very good machine, the performance will be much better. The machine we have tested is on 24-core machine, and we were surprised with the performance benefit we have seen. Yes. Yep.
Do we have priority for the persist2?
Yes, again, very good question. Yeah. So in multi-reader feature I was talking about, we had ability to set the threads on a per bucket basis. So you can say, for this bucket I want 8 threads, for the other bucket I want 3 threads because it's not doing much. So we don't lose that ability. So we still have a setting in our admin UI on a per bucket basis. You can say, I want this bucket to be high priority bucket and the other bucket to be low priority bucket. So
only for bucket level, correct? So
yeah.
The question is like you have a client-side option, correct, where you can say persist2.
Correct.
And it's only few keys you are going to do as a confirmation that I want to have a replica
right.
and I want to have a disk.
Correct.
Compared to you are getting tons of requests to write to the cache and write to the disk.
Exactly.
You don't want to make it blind requirement to have persist2. And so let's say you have writing going on, correct?
Yep.
And the request comes with a high priority.
Yeah.
It's only one request compared to there are 100 requests which is writing to the disk.
Right. So right.
High priority
yeah.
should give a priority. That's what the question is.
So the way it works, and again I was avoiding to answer this question because it's going to be little, it takes time to explain. So basically what we have is queues. So we have high priority queues and low priority queues, right? And when I say the bucket settings and all, the high priority queue will be looked at quite often compared to the low priority queue. So it's, I believe it's 5-to-1 ratio. So the threads basically on the shared thread pool will be looking at the high priority queue quite often, like every 5 times compared to the low priority queue. So if there's any task on the high priority queue, it will be handled first, then the low priority queue. Yeah. Okay, so, right. Yeah, go ahead. Yes. So again, wait till the end because I'm going to have a slide on monitoring and the monitoring stats and alerting stuff. So there we have a bunch of stats we have added. And again, one of the best part of the Couchbase server is admin UI. We collect, like to be precise, 150 plus stats now. And with the DCP, we have added new stats. And I'm going to talk about how to identify if there is a capacity problem or performance problems, and like how to take action on them, right? So we have so related to the high availability, the rebalance operation. I'm going to talk about rebalance operation because it's a very important. I mean, this is a very common operation you perform in Couchbase, right? So rebalance is like when you add a node, when you remove a node, when you do a failover, you have to do the rebalance operation. The goal of the rebalance operation is to bring this cluster to optimal state. Okay, so again, it's a distributed technology, and you have, like if you have 10 node cluster, 10 node server, you basically, what we do is we shard the data, so we evenly distribute the data across all those nodes. So the data movement has to happen, right? So data has to be distributed across all those nodes. When you add nodes or when you remove nodes, again, the data movement has to happen, right? So the data movement is like in the distributed technology, it is unavoidable, it has to happen. So how do we make it efficient? How do we make it performant? And that was the goal of the DCP also, right? So in DCP, so with the rebalance operation, it's nothing changed in the DCP in terms of the rebalance operation in terms of what it does, but in terms of the partition map and everything. But in terms of performance, because it's powered by DCP, what we have seen, I think I have a slide on this. It's 2x faster compared to the 2.5. The reason it's faster is because, as I mentioned in the beginning, DCP has this like bunch of new capabilities of taking snapshot, resumability. In case of there's a failure, it doesn't have to start from the beginning. It can start from where it left off. So it's all incremental rebalance operation, right? So it's much efficient, much faster compared to 2.5. So failover option. So failover is for the fault tolerance, right? Again, going back to the initial key principle about high availability is about to detect the failures and to recover the failure from the failure. So detecting the failure is basically we have a couple of options. We have manual failover as well as automatic failure. You can configure on your cluster. You can enable the automatic failover. There are a lot of constraints. As you can see that we have set a lot of constraints for the automatic failover. The reason is we want to avoid the false positives, right? And that's one of the reasons why it takes now 30 seconds to fail over a server, is because we have to do a lot of things to check in the background to make sure that this is not a false positive, and only then fail over the server, right? So and enabling the automatic failover is simple. You can, there's a setting in our admin UI, or also you can set it through the REST API or CLI command. And also the other thing we want to avoid is cascading failure, split brain, or whatever. So all those things we want to avoid. That's the reason we set the automatic failure for one machine. So at a time there'll be one machine which gets failed over. And if you see there are multiple servers failed, then the administrator has to go and manually fail them over. Yeah.
What's the point if you have to have a manual integration for those kind of autonomous failure?
So let's say that let's say you have a 4-node cluster, right? So you have 4 servers. One of the server goes down, it automatically fails over. But in case if there's multiple servers down, we don't want to, like, if maybe a false positive, or like in case of split brain, what happens is if the 2 servers are on a different network switch, right? And if there's a communication gap between the servers, they will automatically start failing over the servers. So we want to avoid the cascading failure. So ideally behind the scene, what happens is, let's say you have a 5-node cluster and one of the server goes down. In fact, I will have a action, in action, think about the same thing. So here's an example of like 5-node cluster, and I'm going to talk about like how do we do it. So in this case, we have 5-node cluster. Data is evenly distributed. We have active data as well as replica data. We have 2 application servers. Those have the client SDKs installed. They're called smart SDKs because they contain the cluster map. And they also, with the new 2.0 release for the SDKs, they became much more efficient. And in terms of failures, they handle it much better now, right? So in this case, let's say an example where the clients are trying to reach to server 3 in the cluster, and server 3 for some reason it's not able to respond back, right? And at this point, what happens behind the scene is like there's a heartbeat going on between the servers, right? So all the servers have this heartbeat, and if I remember correctly, it's like, I think maybe it's 2 seconds or 5 seconds. So there's a heartbeat going on between the servers. If the server 3 is not responding to any other servers, there'll be behind the scene, there will be a election of new president or like a master. So that master will be a orchestrator, basically it's called orchestrator. So the election process picks up one node across all the remaining nodes and says you're the master. That master starts taking the action. It will mark this node as down, right? And then updates the cluster map and also activates the replica partitions on the other servers. So the client starts talking to the other servers. So as you saw that the whole process is automated, like the process of like taking the server down, marking it down, activating the replica partitions, and updating the cluster map for the clients, and then they start talking to these servers. Everything is automated. Usually after this, there'll be there'll be a rebalance operation so that we want to bring the cluster back to optimal state. At this point, because we have activated the replica partitions, we are missing some replica partitions, right? So we want to be optimal, in the sense we want to go back to the optimal state. So we perform the rebalance operation. Typically what happens is when you take the server out and do the rebalance operation, you're under capacity because you took one server out. It's better to add back the server, bring the server back to the capacity. The way we used to do this before is we had one option which was full recovery. So you can basically fail over a server, take this out of the cluster temporarily, do some maintenance operation. When you bring back, we had one option to bring it back as a full recovery. What the full recovery does is basically it doesn't understand that the server was there in the cluster before and now it's getting added back. It treats it as a new server. So we do this entire data sync from the cluster. So if you had, imagine that you had a terabyte of data on this machine. Now you have to basically get the whole terabyte of data from all the other servers, which is a very unnecessary this network utilization and local resource utilization. So in 3.0, because we have DCP and now ability to do the ordering on a per vBucket process, per vBucket by vBucket basis, we have a new feature called Delta Node Recovery. So as you can see from the screenshot, when you fail over a server, right, when you want to add it back, we give two options: Delta recovery as full recovery. So when you perform the Delta recovery, it knows exactly where the server left before it went out of the cluster. And when you add it back, it knows how much of the data has to catch up, right? So imagine you took the server out for maintenance operation, like security patching, or for just want to reboot the server. So in this case, when you bring back the servers, it has to just catch up like last 15 minutes or 20 minutes, right? So it's the adding back the server is now drastically improved, in the sense you can just basically add back the server quickly. Yep, go ahead.
What's the max duration of that?
I think, good question. I think even Deepu asked this question yesterday. So basically the idea here, that's the reason we have put the full recovery. In case, let's say that you took the server out, you fail over the server, and the server is out for a couple of hours, it makes sense to bring it back with the Delta recovery. Imagine you have taken the server out for more than a week, right? Now you're not sure how much data has changed, or whether the data on the disk is corrupted, or you're not sure, right? In that case, it's always better to go with the full recovery, so it's optimal, right? But again, it goes back to the question is like, are you sure that nothing has happened on the server? You want to bring it back to the cluster. And if you have huge data set, it makes sense to bring it back because you want to be optimized for the network. Right? So we are not, so to accurately answer your question, we don't give you any helpful hints or anything to say that it's good to bring it back kind of thing right now. Okay. Yeah, go ahead.
What you are saying, the master going to mark the server down. So who is the master?
So in a stable condition, in the sense like if you're as a cluster is running, there's no master at that point. Any event happens, for example, failover happens, like automatic failover happens, that's when the master will be elected at that point. So master election process happens when there is any event. If you want to perform a failover option, that's the point where the master will be elected, who does this orchestration process. Yes.
So if you only allow one automatic failover, so
yes.
Have more than one replica.
So let's say you have multiple replicas, and again I'm going to talk about the other failure domains. But the reason I explained to you is basically we want to avoid the cascading effect, right? So basically, if you fail over multiple servers because of false positive, at a time you might take down your entire cluster, and that's like you basically you're basically taking down the entire cluster down, right? So that's the reason we avoid it, and we have mechanism to alert you. So basically, you can say, I want to be alerted when a server fails, right? And you can immediately, you might have even a script ready or something which can basically run when when you get an alert, you can run a script which will go and fail over the servers.
So why not you build this capacity into your server itself, right? You can put whatever customized script and whenever you have it.
Yes, so all these things we have in the UI, everything is RESTful APIs. You can definitely automate the whole process from your side. I think most of the production system, they do automate from their end, right? But in Couchbase, we don't do that.
Why? I mean, this is basically a kind of a problem for operation, right? You have to somebody 24/7 to check the email alert and then take the action manually, right?
exactly. But the thing is that the reason we are trying to avoid, the reason we are trying to avoid taking action ourselves is basically we are not sure. So that's the reason it does take 30 seconds to identify that there is a problem and then take an action. And that's the reason we have put the manual failover, so you know you are in control and you know the best for what's for your cluster. You can take an action for that. I think he's busy with answering. Okay, so you had a question.
Yeah, so let's suppose there is a 2-node
Okay.
cluster.
Yeah.
How would it will recover, because the replica probably be in the multiple nodes, right?
Correct. So let's say, again, depending on how many replicas I've defined, right? So if you have a 3-node cluster, and if 2 node goes down, obviously you lose some replica partitions, right? And if you need durability, you need, in that case, if you need a completely AP solution, right? Available and partition tolerant solution. We have, I'm going to talk about that part in the later, which is the cross data center application, right? You can have a bidirectional cross data center application setup. In case if multiple servers goes down, we have even tools which can be used for recovering the data from the cross data center application, the remote cluster. But if you have a bidirectional application, if 2 node goes down, your application can switch over to the other cluster and start writing to them. Okay. Okay, so I was talking about the Delta node recovery. When you add back the server, we have seen a huge reduction in time. So now this is important for availability, because the sooner you bring back your cluster to the capacity, your cluster is back in the optimal state. Right? That's the goal we want to achieve. So bring the cluster back to the capacity. Okay. All right. Now the question is like, we talked about the intra-cluster application, which is for the data redundancy within the cluster, so that in case if the server goes down, we handle it. But as you grow your cluster, as your Couchbase cluster grows from 10 machines to 20 to 20 to 30 machines, you will not be in the single rack. You start expanding to multiple racks in a data center, right? So there are multiple failure domains. The failure domains can be a single node failing, a multiple nodes failing, or it can be a rack failing, right? So when the entire rack fails, even though the rack has its own redundancy, but chances of the rack failing is there. So we have seen in being big data centers, the rack fails. When the rack fails, the problem is it takes down multiple servers at the same time, right? So if you have 2 racks, and if you had 4 machines on each rack, at one point, if rack goes down, you have lost half of your availability, right? So there, the Couchbase has a protection for that. So we have something called Ragas Own Awareness feature. What it provides is basically we create we group the servers in a server groups, and the server groups are in on one single rack, right? The goal here is to put the replica partitions of one server group in the another rack, so that in case if the entire rack goes down, we still have the availability. So in this case example, we have 3 racks, and each of them have 3 servers, and we have defined 2 replicas for your cluster. So how it helps is like if you see in the red mark, so we have, let's imagine that we have 1 copy in the rack 2 and another copy in rack 3. If even in this case, if 2 rack goes down, we still have the complete key space, entire data set available for your application. So if you, as you said, like if you have more replica partitions, like more copies of your data, and in this case, if you lose 6 servers, you still have the complete availability of the data. So which is great, and since you have your application never sees the downtime kind of thing. Where else the Ragas Own Awareness comes into picture is like basically it's useful for the data centers, like within the data centers, but also if you are deployed on the cloud, on the public cloud, for example. For example, AWS has this concept of zones within the data centers, right? So in this case, the server groups you create can be put in a zone, one single zone, right? So that the replica partitions of this zone is another zone. In case if one entire zone goes down, which has happened in the past, they still have the availability of the data in the cloud. So the Ragas Awareness can be on a data center level, or also it can be used on the zone level. Okay, just explain. So I think I was talking about monitoring and alerting. So as part of the high availability, it's always important to monitor your cluster, right? And I know there's a couple of other presentations where we talk about how to keep your cluster healthy, what are the things to monitor in terms of capacity, performance, and everything. But the Couchbase does provide you like many stats, and I'm going to show you in the demo like the stats we collect from the cluster. And these are more of like we collect across the cluster, and they have and in different levels. We can even aggregate them on a minute basis, hourly or weekly basis. And also these are useful for capacity planning. If you see a performance problem with one machine, you know that something is happening with that machine. You can failover the server, take some action, bring it back, right? And also we have email alerts. So any failures in your cluster, we send an email notification. And here's a list of, if it's visible. So we have a list of the events. If we see these events, we send an email notification. It can be the multiple recipients can be subscribed to the email notification. Yeah.
So what we've seen is, so typically we monitor for some of these stats,
right.
The critical ones. Let's say cache miss ratio.
Correct.
So if my cache miss ratio goes up above 0,
yes,
we can fire off an alert.
correct.
If a node goes down, we've got to wait for an email notification.
Correct.
And then we trap that email and then say, hey,
some action has to be taken. So there's a lag time between that.
Exactly. So
correct.
there is that disconnect between the two.
Correct.
Are there any plans to standardize that so that there is one uniform way of, for example, even getting event notifications?
Exactly. And I think that's in our roadmap. I was trying to, so definitely we are planning to standardize the whole process of event notification. It's alerting is one thing, but we want to also improve our like the event notification also. And also this all alerts on every notification we're talking about, these are all accessible through the REST API. So even now you can basically make your custom application basically to call those REST APIs. Yeah. Okay. Okay.
Is there any plans for anything like a push, like a webhook or anything like that to receive those alerts instead of the email?
Yes, as I've mentioned, yes, we are planning. That's on the roadmap. We don't have any timelines for that, but we are planning to go in that direction.
Push it right to the Couchbase connect.
Exactly. So you had a question?
You answered that.
Okay, all right. Okay, so before I move on to the next part, which I talked about disaster recovery, which is important. And again, how do we achieve the disaster recovery is by geo redundancy. So you have your active data set in one data center, you make a copy of that data in the other data center in geolocated, some other geographical located place. So the way we achieve this is using our cross data center application. And I have a nice animation. Hopefully you guys like it. So basically it's talking about, so you have data centers across the globe, and you can use our cross data center application to replicate the data on the different data centers. Right? It's like we are growing. So in simple terms, what cross data center application provides is basically we have two things. We have unidirectional application, which is between the source cluster and destination cluster. You can set up your application, and it's a granular in the sense if you have multiple buckets, you don't want to replicate all the data from all the buckets. So you can choose and say, I want to replicate only this bucket and not this bucket. So we can do that on a per bucket basis. And over the course of, cross data center replication is not new, right? So it was introduced back in 2.0. What's new in 3.0? I'm going to talk about it in the next slide. But we have done some huge changes over the period of last year. We have added new features like optimistic XDCR, which optimizes your bandwidth. If you know if your data is very small, before we send data to the remote cluster, we always check before we send the data. So that check can be avoided if your data size itself is small. So we have added something called optimistic XDCR. Also, we rewrote the protocol in 2.2, I believe, 2.5 to new protocol for XDCR, which is much more efficient, which goes from memory of one server to the, in terms of the traveling, it's still disk based, and I'm going to touch on that one, but it's much efficient compared to the old protocol. Where the unidirectional application comes to picture is like, what are the use cases is you can create a hot spare, or actually bring up the, yeah. So you can create a hot spare or disaster recovery cluster, a remote cluster where you can, in case if this whole data center goes down because of power outage or natural disaster, your data is still available on the remote cluster, right? Also, some of the cases we have seen is like they have utilized the unidirectional application for development and testing purpose. The bidirectional replication is quite interesting. The reason is because you can set up a active-active cluster. Basically, you have two clusters and set up a bidirectional replication between them. Both the clusters are active-active. They are master-master, so you can take the read and write request on both the clusters. And I was talking about the completely AP system, which is available and fault the partition tolerant, which means that in case if the entire data center goes down, your application doesn't have to wait. It can just switch to the other data center and start sending the request there. So it's completely available and partition tolerant. So again, there are some other use cases, like you can bring data closer to your user. That's the data center locality. And also, as I talked about, the AP system. Yeah.
So is there any performance impact in the multi-directional replication?
No. So the bidirectional in behind the scene, it's what it does simply is like it creates two unidirectional replications in reverse way. So, and the performance-wise, we do. I mean, XDCR is obviously a CPU. It needs CPU, right? So when we do the sizing, in the sense like when we know what's your use case, so you want to set up a multiple data centers, have replication between them, so we size them correctly, and we'll say that. So we have a lot of settings in your So we have a lot of settings in the Couchbase where you can use to fine-tune your replications, like batch size, how much of the what kind of checkpointing you need, and everything. I'll just quickly go through slides. I think I'm running short of time here. So replication, the new in replication here is like it's powered by DCP, and also we have a feature, a admin feature called pause and resume. Very useful feature. Before 3.0, when the XDCR, when you set up a replication, if there is any topology changes, you used to see a lot of errors because there is a vBucket movement or the buckets, the data is getting redistributed. So now in the 3.0, we can basically pause the replication, resume the replication after the topology changes happen. So it's all like everything is handled in the back. So going on quickly, so cross data center replication. Here's one new thing which I talked about. We saw this diagram before. We have the replication queue, disk queue, the same. Since you have set up the XDCR, which is cross data center replication, we will see a new queue here, which is XDCR queue. If I run the animation, you will see that the data comes in, gets asynchronously written to all these queues, and it gets sent to the other cluster. The goal we want to achieve here is for the geo redundancy is like send this data quickly to the other cluster. So in case if this whole data center goes down, we still have the availability. The sorry.
Does the replicate tool also work with XG?
Very good question. Right now it doesn't support. So in future we might even plan to, because it's a DCP based, we have ability to do that one. But right now in 3.0 it doesn't support it. Sorry. The question was, does the replicate2, the API which I showed you in the beginning, does it work with the XDCR also? So that doesn't work in the 3.0. Yeah. Actually, you know what? I think the performance, 4x better performance, latency it's drastically reduced because it's memory based. We send the data quickly to the other servers. Okay, I'm going to quick switch to the demo. Man. Okay, demo is the important part here.
You said the demo was the coolest part.
Yeah. So by the way, just quick thing, if you have multiple data centers, multiple clusters of Couchbase, you can name them. So you can see the names here on the top. Hopefully this.
Yay. Kind of resolution.
Okay. Okay. Okay, so a couple of things I showed before, like from the demo, it'll be a quick thing. When you fail over a server, like you can say, it gives you a couple of options, graceful failover or the hard failover. The hard failover was there in the beginning, but the graceful failover is new in 3.0. What it gives you an extra like peace of mind, because when you fail over a server, before it immediately took the server out. So we didn't wait till the in-flight data has caught up, right? So graceful failover waits for the data synchronization to happen, only then fails over the server, right? So when, let's say I'm doing the failover, failover happens hopefully quickly because the bucket is empty. So now, in this case, you see that the server is out, right, in the pending state. I can add the server out after the maintenance operation, and I can say, I want to do the delta recovery for this guy, and do the rebalance operation. Okay. So it comes back to the server very quickly when you compare to the 2.5. The few things I wanted to show, but I think I'm running out of time here, is XTCR. Actually, hopefully my other cluster comes back. Okay. Meantime, I will come back here. These are the stats we collect from the cluster. There's a bunch of them. There is a new stat we have added for DCP queues. I want to talk about this. So we basically has categorized into the main guys who are using the DCP. So replication, which is intra-cluster replication, is the main consumer. XTCR is main consumer. Views is the main consumer. So we have incremental backup and restore, which will be the other consumers. So you see number of connections for the DCP. You see number of bytes transferred and all this new stats for the DCP. So one thing which I want to cover about is like the incremental backup restore. So I think I missed covering about is, yeah. We have a new backup restore tool which is called incremental backup restore. We can create a differential backup or cumulative backups, which is much efficient. It takes the backup in a small and faster, and also in terms of size, it is much smaller size. Okay, I think I'm done. Thank you.